What's up, guys? Obviously, I'm not here today, so I decided to record this lesson rather than have it be another missed day here. So I'm going to actually skip lesson 5 until I'm there in person. So if you have your note packs or if you want to grab your note packs out, we're going to skip forward to lesson 6, which is looking at solving quadratic equations by graphing, which is on page 16 of that note pack. The other thing that you're going to make sure you need to have for today is your graphing calculator, because like this says, we're going to go look at solving this graphically, and we want our graphing calculators to help us do that. Okay, so what we have looked at so far in this quadratic section is what is called a quadratic function. Oops, didn't mean to cross that out. What's called a quadratic function. And so a quadratic function is when we have two variables that are related together. So an example of a quadratic function is like something we've seen before where we have, y equals -2, x minus 3 squared plus 5, something like that, okay? Where I have both an x and a y in my quadratic function. So functions have two variables. Another example of something that could be a function is if I have, like f of x equals x squared minus 4. That's also considered a quadratic function. And we should know the characteristics of about, what makes a graph a quadratic function, which is the second degree. I should be able to look at this graph here and be able to tell the opening direction, which is going to be down. I should be able to tell the coordinates of the vertex, which would be at 3, 5. And it also has that vertical stretch of 2, because that is in vertex notation. We should know all that information. And so that's what a function is. Quadratic functions have two variables in them. So what we're going to be focusing on from this point forward is quadratic equations. And so equations involve only one variable that can be solved for. So in a quadratic equation, there's only one variable and we can solve for it. So for example, if I had, x squared plus 15x equals 16, I could go ahead and actually solve that if I wanted to. Another one could be like if I had x squared minus 5 equals 2x plus 3, right? There's only one variable there. And if there's one variable there, I can solve for it. And our strategy for the next few days is going to be looking at all of the different ways we can solve quadratic equations. Another example of a quadratic equation that we could solve would be like, x squared minus x minus 6 equals 0. There doesn't necessarily have to be numbers and variables on both sides. They could all be to one side, and I could still look at how some strategies that I could solve that. So the first thing we're going to go do here today is looking at how we can solve this set of quadratic equations graphically. The first way to do this is going to be with our graphing calculator. That's what today's lesson will focus on. And there's two ways that I can solve with my graphing calculator. The first one we're going to look at is called the intersection method. So what's happening in this is I have two sides to an equation, okay? And if I have two sides to an equation, I'll graph the left equation and I'll graph the right equation. Once I've done that, I'm going to find all of the intersecting points. So graph both the left and right side, find all the intersecting points, and then use only the x values to solve. So if I want to write down or kind of say what I'm going to do on my graphing calculator here, I take the left side. I'm going to go type this in as y1. Take the right side. I'm going to go type that in as y2. Okay, that's this first part right here. Graph both the left and the right side. So I'll bring up my graphing calculator and I'll do that. So y is equal to 3x squared minus 12. And my other equation is equal to 5x. And so I can go graph that on my calculator. And so there we can see both of those graphs are coming up. I can see that there's like an intersection point down towards the bottom part, and there's probably another one in the top right. So I'm actually going to zoom out a little bit so I can see both of the intersecting points here. Okay, there we go. Not great to see, but I can see that there's two intersecting points there. So if that's what I just did, I'm going to write that just the notes down for myself. So I graph this. And according to my steps up here, I need to find the intersections. So on my graphing calculator, now there's all of those different functions I can go solve for. So if I go to second trace, gets me to the calculate function, and there's all of the different things I can go solve for. Right now, because I have two different equations, y1 and y2, I want to see where they are equal to each other. So where do they cross each other's paths? They would cross each other's paths at the intersect. So I'll go hit number 5. Now, if you are looking towards the bottom of your calculator screen, it says first curve, question mark. So it's saying like if you had, maybe I had 4 or 5 graphs on here, it would want to say, it's trying to ask you what 2 graphs do you want to find the intersection for? So the first curve, I'm just going to hit enter. Second curve, hit enter. Unless you have more than 2 graphs on there, you should just be able to hit enter, enter. Then the second one is a guess. And so I want to bring my cursor. I'm going to bring my cursor down towards this bottom left intersection. And so I'm going to guess somewhere down here, and I'll hit enter on my calculator again. And then my calculator tells me, hey, there's an intersection right here at negative 1.3 repeating and negative 6.6 repeating. So I'll go write that down. That's at negative 1.3 repeating and 6.6 repeating. No, sorry, negative 6.6 repeating. So I found one intersection. I want to go find the other because I can see there's another kind of up in the top right here. So second trace gets me to the calculate function, and I'm going to go find the intersection. So first curve, just hit enter. Second curve, enter. Guess. Now I'm going to bring my cursor. Now I'm going to bring my cursor up to the second intersection. If I do not move my cursor close enough to the second intersection, it's going to pull me back down to the intersection I've already found. And so it says, hey, there's an intersection at 3, 5. So I'd write that second point down. So, and there's an intersection at 3, 5. Now, really, if I look at this equation is focusing only on the x values, right? I can't put a y value into this equation because there's no y value there. So the answers that I'm looking for here is the x values, and it says round to the nearest hundredth. So to solve for this, my final answers would be x would equal to 1.33 and 3. Now I could go solve and verify that answer if I'm like, I'm unsure if I did that right. Well, what I do is I take this and substitute it back into the equation, and I want to see if the left side is equal to the right side. So I would go 3 times, let's say, 3 squared minus 12. So 3 times 3 squared minus 12, if I can throw that in my calculator, or that's 27 minus 12 is 15. And I want to know, does that equal 5x, right? Because apparently 3x minus 2, we're trying to find out where that equals 5x. Well, 5 times 3 is also 15. So I know that that point works. And I could also go check my 1.33 if I wanted to. All right, next one. I have information on both sides of my variable here, or my equal sign. So if I have this and I'm trying to solve graphically, I can just graph this for y1, graph this as y2. I'm going to go graph this and find the intersects. I want to find out where those two equations could equal each other. This one I could actually solve pretty simply algebraically, but we'll go do that in a few days. So right now, we'll just look at solving this. So on my calculator, I'll clear this. And again, so the left side is one equation. So the left side is x minus 4 squared. The right side is just 25. So I just type in that constant of 25. And then I should be able to graph it on my calculator and hopefully see both of them. There we go. So a quadratic function and then just a horizontal line. And so now all I need to do on my calculator is to go find the intersection. So second, calculate the intersect, number 5. So first curve, enter. Second curve, enter. Guess, actually brought me right to the intersection. I'll just guess right there. Tells me there's an intersection at -1, 25. And we'll go find the next one. Oops. And we'll go find the next one. So second, calculate the intersect. First curve, second curve, guess. I just got to bring my, why does it keep jumping like that? First curve, second curve, guess. I'm going to try and get as close to that other intersection as possible. So somewhere around there. And my calculator is like, yeah, there's one at 9,25. Okay. And again, looking at this equation, so there's only x values that would work here. So I need x is equal to -1 and 9. And so if I kind of think about this in my head, it should work, right? Because -1 minus 4 is -5, and -5 squared, which is -5 times -5, is 25. So that's good. And then if I substitute the 9 in, 9 minus 4 is 5, and 5 squared is 25. So both of those answers make sense if I try to verify them. All right, that's the first method, solving with intersections. So that means you have an equation on both sides, y1, y2, and I just graph them accordingly and find their intersections. The second method here is solving for zeros. And so what's happening in this case, if I'm going to try to solve with my zeros method, is I need to make the equation equal to 0. And so that means that on one side, there needs to be a 0, and all of the other information needs to be on the other side. And so when I'm moving things around, remember you're using opposite operations. So if I have a 2x, to move a 2x, I need to subtract 2x. The solutions are the x-intercepts. So with a zeros method, what you end up actually finding here is the x-intercepts. So I'm just going to go write a few steps that we can do to solve here. So to solve with my zero method, I first need to bring all the terms to one side. So bring all terms to one side. And really what's happening here is you're making the equation on one side, and then it's going to equal 0, or maybe 0 equals an equation, whatever way it's easier to move. Next thing you want to do is graph it. We're still trying to solve with our graphing calculator. So I'm just going to graph the function. And the third thing I need to do is find the x-intercepts. And so if I'm solving for my x-intercepts on my graphing calculator, it's actually called a 0. And so hence why this is called a zero method, is because we are finding the x-intercepts, which are also called zeros. Now, when I am solving a quadratic method or a quadratic formula in this form, there are a few different possible outcomes, right? If I'm thinking about a quadratic equation, well, it's possible for that quadratic equation to touch, go past the x-intercept and come back. And so in this case, I would have two real roots. So I have two x-intercepts, right? X-intercept here, x-intercept here. Or, I could have something that looks like this. And I still have, two x-intercepts. Well, how could I have this work so I only have one real root? Like how could this work if there's only one x-intercept? Well, in this case, if there's only one x-intercept, what happens usually is the graph comes, touches the x-axis, and then bounces off. So it only touches at one point. And obviously the reverse could work here too. If I come up, touch that, and then go back down in the other direction. In that case, there's only one x-intercept. There could also be points where there are no real roots, right? I can't have a quadratic function that's just like totally up here and it goes forever in both directions and doesn't even cross the x-intercept, or the opposite function, reflection, which would just be down here. And so there's no x-intercept. So when you're graphing these equations, you need to be aware that you might have two answers, you might have one, or you could have none, depending on the information that equation you're looking at. Okay, so let's go look at how to solve this. So it says solve the following equations by graphing, rounded to the nearest 100. Well, they actually already gave me this in, zero form. I have an equation equaling 0. And so what I want to do is I'm just going to graph this guy as y1, graph and find the zeros. So I'm looking for the zeros in this case. So y equals, I'll just clear all this information because I don't want two lines. And I will type in that equation. So 2x squared plus 20x plus 42. So I'll graph that. And there we can see it. I'm actually just going to go zoom 6, get me to my standard window, and I can see it a little bit clearer there. Now, I could probably look at this and just guess, like, oh, it's probably at -3 and negative 6 there? Did I graph that right? 2x squared plus 20x plus 42. Okay. I could probably just guess what these are. Like I can kind of, narrow it down. It's probably at -3 and -7 or 6. But I actually want to go graph this or find it myself by using the zeros method. So I go to second trace and I go down to 0. And so 0, I use that every time I'm trying to find an x-intercept. And so again, my calculator, it starts asking me questions to try and narrow down the range that I might have this 0 in. So I'm going to go try and find the far left x-intercept first. So it says left bound. And so what you need to do, can't even see my cursor yet. There it is. I need to bring it to the left of this x-intercept. So the left of this far x-intercept is going to be up here. Like where on the line is left of that x-intercept. And so that would be there. So I hit enter. Right bound, I'm going to drag it past there. So it's got to be where on the line is right of that x-intercept. So it's on the negative side. And so you can see these arrows at the top you're telling your calculator, oh, there's an x-intercept somewhere between these 2 points. And guess I'm just going to get kind of close as I can there. Hit enter. And it says, hey, there's a 0 at -7, 0. So -7, 0. And I'll go find the next one. So second, calculate to 0. So left bound, anywhere over here is technically to the left of that x-intercept. So left to the right of the other x-intercept. I just got to pull my cursor. Right past it, hit enter, and then guess. So I'm going to guess right around there. And my calculator is like, yeah, there's a 0 at -3, 0, and at -3, 0. I can always go check those if I want. But again, you also need to kind of say x is equal to -7 and -3, because those y values do not play any part in this equation. Okay, the next one here is x squared plus 10x plus 25 is equal to 18. So where does, we want to solve this with the 0 method. And so my problem right now for solving with the 0 method is that there's not everything on one side. Hypothetically, it's probably easier for me to just go solve this with the intersection method, graph that as y1, y2, go find my intersections. But that's not what they're asking me to do. So what I need to do is get all the terms to one side. So I need to move a positive 18 by subtracting 18. So x squared plus 10x and 25 minus 18 is going to give me 7. So plus 7. Where is that equal to 0? And so now that I have everything on one side, I can just go graph this as y1. And I graph it and find my zeros. So I'll go back to y equals and write that down. So x squared plus 10x. Oops, sorry, I'm going to put the plus there. Plus 10x plus 7. You can go graph that. Should be able to see kind of a rough draft of that graph there. And so I'm going to go second, calculate the zeros. So to the left, I'll do the close one to the y-axis here. So to the left of there on the graph would be left. So hit enter. To the right, I'll bring my cursor to the right side of the x-intercept on that line. Hit enter and guess. Somewhere around there is good. And it tells me there's a 0 at what looks like some quite gross irrational number. So I'm just going to round to the nearest hundredth. So this is negative 0.76. So x is equal to, I'm not even going to write my, I could technically write that as negative 0.76 comma 0, but I'm not even going to write that because I don't need the y value. So I want to go find that far left intersection. So second, calculate the 0. And so left bound, I'm going to start dragging my cursor. I got to get to the left of that point, which is like somewhere past, negative 10. Oh, there we go. So now I'm left of it, hit enter. Right of it, bring it past that point on the right side is down here. Guess somewhere around there. Negative 9.24. So, and negative 9.24. If I wanted to, I could verify. I could go solve with my intersection method and see if I get the same answer. But we'll circle that for my final answer. Okay, there's a few word problems here, not in the same kind of word problems as was going to be in lesson 5. So I think we should be able to look at these and solve at least example number 4. I'll probably do example number 3 with you guys in class. So example number 4. So now we're kind of looking at like real world applications of quadratic, like, mostly trajectory questions. So it says the function h of d, so the height compared to the distance, is equal to negative 0.025 d squared plus d. And that says it models the behavior of a soccer ball when it's kicked. H represents the height in meters, and d represents the distance the ball travels in meters. Determine the horizontal distance the ball travels when it hits the ground. So I'm just going to go rewrite this equation here so we know exactly what's happening in this equation. Okay. So it says this is talking about the distance of the ball, which is essentially related to your x value, right? H of d is saying this is the height of the ball, which would be relating to the y value because that's on the left side. It's saying determine the horizontal distance the ball will travel when it hits the ground. So if I have a real world problem, what I want to do, and right now we're just looking at using your graphing calculator. So we'll go graph it on our calculator. Then we'll try and understand what's happening with respect to the question. So let's go graph this. Y equals negative 0.25 dx, which is now d squared plus d, which we're saying is x. So if I graph that, that doesn't seem right. Oh, I missed a 0. All right, negative 0.025 x squared plus x. There we go. So I graph that, and I can see, and then it kind of goes over to the right there. Now, I could zoom out here. The problem is if I zoom out, I kind of end up with like a really gross graph. So another way that I can change my window is to go to this button right here next to zoom that says window. And so it's saying like, talking about your x values here. So it says, what is the minimum x value you could be? So the minimum x value, so what is the least amount of distance I could kick a soccer ball? Well, the least amount of distance I could kick a soccer ball is 0 feet or meters, whatever we're talking about. What's the maximum distance I could kick a soccer ball? Well, I mean, maybe I could kick it all the way across a football field. Like that'd be a pretty far kick. So let's go with like, I don't know, 75 maybe. And so that's talking about my x values. I always leave this XSC1, that's just talking about the scale, leave it at 1 for now. The y minimum. So now we're talking about y with respect to this question is talking about height. So what is the lowest height you could kick a soccer ball? Well, it's just on the ground, right? It'd be at 0. What's the highest distance I could kick it? I don't know. Maybe I could kick it like up high against gravity. Like, I don't know, 20 meters would be like a lot. I feel like maybe not. I don't know. All right, there we go. So there's my graph. And so I'm going to give myself a little sketch here to see what's happening. And so we went from 0 to 20 on the y, and we went from 0 to 75 on the x. And I'm just going to kind of try and copy that. So it looks something like this. Now, maybe you pick different numbers for, your X here and your Y. That's fine, as long as you can kind of see the function here. Or maybe you just zoomed out. Doesn't matter. The thing we need to do is answer what's happening in this question. And so the question says, determine the horizontal distance the ball will travel when it hits the ground. So essentially, I take the ball, I kick it, and it's going in the air, reaches its top height. That's not what they're asking. Reaches its top height, and then it continues downward until, boom, right here, where it hits the ground. Now, if I'm looking to solve for that point, what is that point? Well, that point is a x-intercept. And to solve for an x-intercept on my graphing calculator, I'm looking to solve for a 0. So I can go do that. So second, calculate the 0. So left of that 0 would be here. To the right of it, I got to pull it down, probably make sure my y values are negative, which they are. Hit enter. Oh, didn't like what I just did. So I'm going to go calculate my intersection, or sorry, my 0. I'm going to go calculate my 0. So left of that far x-intercept is up here. To the right, I got to pull it down. I'm just going to go down a little bit. My y is negative, so I'm obviously below the x. My guess, somewhere right around here. And so it's at 40, 0. So at 40, 0. And so if I got a word problem, I should answer my question in words. So therefore, the ball traveled 40 meters before hitting the ground. So you guys will take some time here to practice solving graphically and look at a few word problems. Now, a lot of the word problems might be a little bit more difficult, and so we'll come back when I'm back and do the word problems together, the more difficult ones. So what you guys are going to work on right now is homework 6, numbers 1, 2, 4, which I don't think should take more than, 20 minutes, half an hour. So. All right, take your time, check your answers in the back.